questions part of our particular lesson for today. So let's start with this, solving a percentage problem. Go ahead. Okay, so we did our typical stop and start, which I don't feel compelled to tell you anymore. You should know that by now. So here's the bottom line. You're going to purchase a jacket with a labeled or a pre-tax price of $127, but the local sales tax is 7%, and you bought enough items in your life to know that tax is paid on top of the cost of the item. What is your final cost including tax? Now the final cost is the labeled price plus 7% of the labeled price. So the final cost is the labeled price plus 7% of the labeled price. Kind of like factoring out here. You could pull out the 100% and the 7% to make 107% times the labeled price. So that's 1.07 times the labeled price of 127 works out to be 135.89. So that's a little review of a percent problem. Now, let's go to a rule of 72 question. Go ahead. So the rule of 72 says if you take 72 and divide it by the interest rate, it tells you how long in years it takes to double the money. Or if you divide 72 by the number of years you need it to double, it tells you the interest rate you have to get. So if she invests $7,000 into an account that earns 12% compounded, very important because the rule of 72 only works with compounded interest, how long until it doubles, and how much money will she have in 18 years? So the easy part is how long until it doubles. So 72 divided by 12 is 6. So in 6 years, the money's going to double. Now, here's my table. In 6 years, I made a mistake in this table. Let me go back and correct. In 6 years, you have 14,000. And then in 12 years, you have 28. And then you have 56. So years doubling. So in 6 years, if you started with 7,000, 6 years later, you're up to 14,000 because it doubles. 12 years later, you're up to 28,000. And 18 years later, you double it again. That's $56,000. So how much will she have in 18 years? She'll have $56,000. Okay, here we go. Use the compound interest formula for compounding more than once a year to determine the accumulated balance of $70,000 if that's invested at an APR of 2.75% compounded monthly for 8 years. Go ahead. Okay, so the formula is the amount in the account equals P times 1 plus R over N to the NT power. So that's 70,000 plus 1 times 1 plus 0.0275. The interest rate is a decimal divided by 12. And then for the exponent, it's that same 12. Those ends are always matched times the time, which is 8 years. So there's the numbers in front of you. It's 70,000 times 1.00229166667 to the 96th power. That works out to be $87,203.42. Okay, now some more review type of questions. So this reviews writing out equations, and I don't remember exactly when we covered this, but I do remember that this is something pounded in public schools in 8th and 9th grade. This is hit so hard as part of the Common Core curriculum. And what you're supposed to notice here is that the trunk diameter is going up 0.6 inches, or 0.6 inches per year. See, 18.6 plus 0.6 is 19.2. Plus 0.6 is 19.8, plus 6 is 20.4, and so on. That's for tree 1, and that's the only equation we're dealing with here, so I won't bother looking at tree 2. A scientist creates an equation that models her data for each tree so that she can predict the diameter in the future. Complete a linear equation that fits for tree 1. X is the year and Y is the trunk diameter. So Y, the trunk diameter, is something, 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 and we have to fill in from here. So the first thing I'm going to fill in is x, because this is like y equals mx plus b when you go to graph a line. And since you're going up by 0.6, that means that that's the rate of change or the slope, and that's what goes in front of the x. So we get 0.6, and we have to know what was the diameter of the trunk when we started at year 0, not at year 1. So if they're going up by 0.6 a year, I got to subtract 0.6 from 18.6, and I began at 18. So the correct equation is y equals 0.6x plus 18. Now, I actually think that this is not so much a review question as much as it is a praxis problem, and somehow this got put into the wrong area. But there were many questions like this on the practice tests that I went over. So this is the first time that we've seen it, and probably the first time that you've seen it since high school. So don't worry so much if you didn't get it correct. And I'm sure we're going to come back to it again and work on tree 2 in the future, and also maybe change the numbers in tree 1 and see what we come up with. Okay? All right. Let's go to the next one. Go ahead. By the way, this is a question that came from your quiz. It was one of 3 questions that there were more than expected level of difficulty on. I'm reviewing 2 of them this week. The other one I will get to at some point in the future. So I want to make sure we hit this one so that we're better at it. Go ahead. Okay, so notice it says how long until Bill's account has 192,000 in it. So what I have to do is figure out first what is, by the rule of 72, how long it takes to double, and that's 72 divided by 12 is 6. So if I start with 24,000 in the account, I'm sorry, I started with 12,000 in the account. In 6 years, I'll have 24,000. In another 6 years, I'll have 48,000. So we're up to 12 years. In another 6 years, we'll have 18,000. And this is not saying 18 is greater than 96,000. This is like an arrow pointing here. And then in 24 years, we'll have 192,000. So in 24 years, you'll have $192,000 in the account. Pretty good for a $12,000 investment. Oh, that's when people talk about saving money. They're not talking about the local bank. They're talking about long-term savings like this, where you get compound interest for investments. And last but not least, this is another question that students had difficulty with. You can see the answers put in front of you. All right, so I equals PRT. I pump in the 1500, the 0.03, and the 7, and I come up with $315.